Okay, today's going to be about logarithms and exponentials and how they are inverses of each other, and to sort of get you understanding the definition of a logarithm. Okay, so the easiest way to define a logarithm, a log is always equal to an exponent. What I mean by that is if I say something like 2 to the third is equal to 8, and I wanted to rewrite the expression using a logarithm, I would say log base 2 of 8 is equal to 3. Okay, so let's just look at these two expressions for a second. We said, well, 2 was the base here. This is log base 2. Okay, 3 was the exponent here. Well, a log is always equal to an exponent. And then 8 is the number you're comparing the base 2 to. So log base 2 of 8 equals 3. And that's how you express that in language. So log base 2 of 8 is equal to 3. So that's how we verbally express a log. Now, when we look up here, just a second, I'm going to go back a screen. When we look at just this pattern, let's just take a look at this pattern. 10 to the negative 3 is equal to 1 over 1,000. 10 to the negative 2 is equal to 1 over 100. 10 to the negative 1 is equal to 1 over 10. 10 to the 0 is equal to 1. 10 to the first power is 10. 10 squared is 100. 10 cubed is 1,000. Now, if we rewrite these expressions using the logarithm, I would say the log of 1 over 1,000 is equal to a negative 3. I would say the log of 1 over 100 is equal to a negative 2. I would say log of 1 over 10 is equal to a negative 1. I would say log of 1 equals 0. I would say log of 10 is equal to 1. I would say log of 100 is equal to 2. I would say log of 1,000 is equal to 3. Now, what we notice is we call these common logs. So common log is equal to any log that's base 10. So when it's base 10, we just say that it's a log. So it's the 10 is understood type of thing. So pause this if you need to. I'm going to the next screen. Okay, so up here we can say now that log x is equal to log base 10 of x. So the 10 is understood. Okay, now this is what we call a domain restriction. So it says that my x value has to be greater than 0, or I'm sorry, that should be my base. Let's just say that it's base. So whatever your base is, pause. Oh, sorry about that. I had to erase that because it was not the base. It was just log of the x. I was making a mistake. So anytime you have an expression where this value, let's say it's the log of a negative 2. Let's just do that. So log of a negative 2. Now this has a common log as a base of 10. So when you hit this LOG button on your calculator, it is the base 10 log. And if I say negative 2, put it in there, it's going to give me a non-real answer that is called a domain restriction. Okay, so we cannot take the log of a negative number. That's what that means. If we have a log that is not base 10, we have to do what's called the change of base formula. Okay, and the change of base formula is right here. Okay, so if I say the log base 3 of 5, then I got to say the log of 5 over the log of 3. Okay, and so since my base here is 3, we say base on bottom. So we can rewrite the expression to get the correct answer. In other words, in your calculator, you could say alpha y equals, and you could say log, and you could put base, but they could put log of 5, base 10 log, over log 3, and it would give you the right answer. Okay. And you want to keep these to probably 3 decimal places, so that would be 1.465, roughly, approximately. That would be the value of that exponent. So now if I say 3 raised to that, I want to say clear that. If I say 3 raised to that expression, then that means that's equal to 5. Okay, and you can see there's a round off error, but you can see basically that's what we're referring to. Okay, that's giving us the proper exponent. Okay, so there's ways to solve simple logs like I have here. This m is my base raised to the w is equal to c. I want to rewrite that expression using a log. So we're rewriting as a logarithm. Then I am dropping the base, and I am switching these two numbers to where the w is over here by itself, and the c is attached to the log base w. So we call that drop and switch. Okay, now if I want to rewrite as an exponent, I want to rewrite let's say rewrite in exponential form. Then my base goes up, and I switch these, so it's up and switch. So basically log base 3 of x equals 2, rewrite as an exponent is 3 squared is equal to x. I could even solve that though. So this is me solving here. So I solve for x here. So 3 squared is equal to 9, right? But me rewriting in exponential form was indeed just that. Pause if you need to. I'm going to the next three. So in these couple examples, we're going to go back and forth. They give us exponential form. We're going to rewrite it in logarithmic form. They give us logarithmic form. We're going to rewrite it as an exponential. So in this very first one, they told us our example was 2 cubed is equal to 8. And I did this earlier. So you just realize that you're going to drop your base. So this will be log base 2, and then switch the numbers, right? So that's going to be log base 2 of 8 is equal to 3. Now, another way you can think of it is doing a backwards C. You start at your 2, then you go around to your 8, and then you end up with your 3. That's another way to think about it. In this next expression, we're going to write as an exponential, so we're going to take our base up, so it becomes a larger number. And we're going to switch these two. So 9 squared is equal to 81. So we have just rewritten exponential into a logarithmic, and now we've rewritten a logarithmic into an exponential. Pause if you need to on both. Okay, you give these a shot, and I'll work them here in a minute. So pause your screen, work them out, and then come back and unmute and see how you did, or unpause and see how you did. Okay, so this is clearly exponential. If you don't see the log, it's in exponential form. So basically, we are going to have to drop the base. So that's going to be log base 5. And we're going to switch these two numbers. So 25 equals x. Now, if we wanted to go further and solve that, we could say, well, that's log of 25 over log of 5. Equals x. Okay, so, but that wasn't the question. But then if we wanted to find the answer for x, we would just simply solve it. We would say log 25 over log 5. Should give us 2, right? Okay, in the next problem, they want us to go from exponential to logarithm again. So I would say this would be the base I'm going to drop is going to be log base y. And then 37 and 5 are going to switch. Right? So I drop that and I switch those. And there's really nothing to solve here. You could not, don't think about it. We could solve this, but you're not ready yet. That'll be another lesson. Right now we're just converting back and forth. When we look at this next one, they want us to rewrite it as an exponential, so we have to do up and switch, right? We're going to do up and switch. So the 2 becomes a big base, and then the log is always equal to the exponent, correct? So that's going to be 2 to the 5th is equal to 32. Okay, and if we understand the definition of a log, that a log is equal to an exponent, then we understand that the 5 is the exponent, and let's go on the exponent spot. Okay, and the last one here is going to be x is the base, 6 is the exponent, and then 135 should be so that's why we switch those. And we could solve this expression here. We could probably solve this expression here, but that's not what the lesson is about right now. So that's where we're headed, though. Pause if you need to. I'm going to the next screen. Okay, so here's 4 more for you to give it a shot. So go ahead and try these 4 and pause your screen now, work them out, then see how you did. Okay, so let's look at the first one. Since we are going from a exponential to a base, we need to drop and switch. So we dropped the base, so log base 5 of 125 equals 3. In example 6, we have given a logarithm. We want to rewrite it as exponential, so we got an up switch. So that's going to be 3 squared is equal to 9. Now, we normally don't write the 10 here, but since we're just learning, the understood 10 is written in this problem. Okay, so keep in mind we are going to be performing up switch again. So 10 to the negative 2 should equal 1 over 100. And last but not least, another log. So we are going to do up switch. So 5 to the 4th should equal 625. Okay, pause your screen and make sure you got your answers right, and I'll be moving on. Okay, we're going to find the inverse of an exponential function. So this is the direct application of finding the inverse of a function. So basically, we will replace f of x with y. We will switch x and y, and then we will solve for y. So f of x is equal to 2 to the x. Therefore, y is equal to 2 to the x. Now, I want to find the inverse of an exponential. That's a log, right? So I'm going to need to do drop and switch. And when we drop, the log goes to the basement. So log base 2. Oh, I didn't switch x and y. I'm sorry. So we need to switch x and y. Let's move this. Let's switch x and got ahead of myself there. So this is going to be x is equal to 2 to the y. And then we drop and switch. So now we're going to say fine. That's going to be log base 2. So x is equal to y. Okay, pause if you need to. I'm going to go to the next screen. And just remember, when you say that you're doing the drop and switch technique, you are rewriting in logarithmic form. Okay, so let's find the inverse of this. we're going to find the inverse of this. So the first thing we are going to do is switch x and y. So x is equal to 2 to the y plus 3 minus 2. Now we are going to isolate our base. So we are going to say x plus 3 is equal to 2 to the y plus 3. And then we are going to rewrite as a log. So that means we're going to do a cross switch. So we are going to say log base 2, and then parentheses x plus 3 is equal to y plus 3, which was the exponent. So remember, a logarithm is equal to an exponent. Now to get y by itself, the last step will be to subtract 3. So that means y will equal log base 2 of x plus 3 minus 3. Pause if you need to. Okay, for this one, we're going to graph a more simple, we're just going to graph 2 to the x. So we're going to graph y is equal to 2 to the x. Oops. And so we need to make a table for that. So x, y, negative 2, negative 1, 0, 1, 2. And then this is going to be this 0.25, 0.5, 1, 2, and 4. Basically, we can think about that. It'll have a horizontal asymptote. And we will graph these values. So negative 2 is pretty low, negative 1's halfway, 0's 1, 1 is 2, and 2 is 4. Okay, and this is the basic graph of an exponential function. Okay, well, what's the inverse of this? Well, the inverse of this is going to be y is equal to log base 2 of x. Once we go through the steps, again, the steps were switch x and y, x is equal to 2 and then perform drop and switch. So log base 2 of x equals 4. So that's where I'm getting. Now remember, these tables should switch, shouldn't they? If they're true inverses, we can just say this is x and this is f inverse of x. So basically this would become 0.25, this would become a negative 2, this would become 0.5, this would become a negative 1, this would be 0, or sorry, this would be 1. And then this would be 2, and this would be 1, and this would be 4, and this would be 2. So we basically, and double check and make sure that you reversed it correctly. Sometimes I'll get those numbers backwards. And then we will plot those points. Now, this time we will have a vertical asymptote. And these points, so 0.25 is a negative 2. 0.5 is a negative 1, 1, 0, and then 2, 1, and then 4, 2. So you can see this graph, what it does. Okay. And you should be able to still see symmetry on the y equals x line to show that they are inverse of each other. And keep in mind that I drew the blue one, the blue stuff by hand, so I'm only going to be so accurate with that. So keep that in mind when you're looking at these. Okay, so we can see that this logarithm definitely has a domain restriction. So now when you think about a log, you go y is equal to a log, so we'll do c. This will equal b log c x minus h plus k. That would be sort of the transformation graph you would need for that. Okay, Okay, so pause if you need to. I'm going to the next screen. Okay, now for this problem, we're going to find the inverse. And so they're giving us an exponential function, so the inverse would have to be a logarithmic function. So the first thing we want to do is rewrite with y instead of f of x. 4x plus 1 is the exponent. Okay, keep that in mind as you're doing that. So this would become x is equal to 5 times 4 to the y plus 1 over 2. Now keep in mind we need to isolate the base, which is 5, so we need to get rid of that 2. So we're going to multiply it to the other side. If you think of this, this is just like a proportion. Okay, so this would become 2x is equal to 5 to the 4y plus 1. Now at this point, we need to perform drop switch. So it's going to be log base 5, 2x is equal to the exponent of 4y plus 1. And then we need to solve for y. So we're going to say log 2x should be in parentheses. Log base 5. You got to always group with a log. Minus 1 equals 4y. And your final answer will be y is equal to log base 5 of 2x minus 1 all over 4. Okay. Give it a minute with this again. Pause if you need to. Okay. In this problem, I want you to find the inverse. Go ahead and write the problem down and pause it. Turn it back on to see if you get it right. Okay, so the first thing I'm going to do is say y is equal to 1.5 x plus 4. Then I'm going to switch x and y. Say x equals 1.5 y plus 4. Keep in mind that your variable y went up to the exponent area. The only way to get it down is with use of a logarithm. So we'll say x minus 4 is equal to 1.5 raised to the 1. Now that my base is isolated, I can take the log. Now keep in mind the log, I'm going to drop the base, so log of 1.5. X minus 4 has to go in parentheses to y. So that's your final answer. Pause it. Okay, so keep in mind the logarithm's equal to an exponent. That helps here. We're still finding the inverse. First thing we're going to do is take x and y and switch them. So x is equal to log base 5 of 4y plus 1. Now what's in the exponent position? The x is in the exponent position. So when we do up and switch, we're going to say 5 to the x is equal to 4y plus 1. 5 to the x is equal to 4y plus 1. So the 5 goes up, and we switch this term with this term. Now we're going to solve for y. So we say 5 to the x is equal to minus 1 is equal to 4y. And then we say y equals 5 to the x minus 1 all over 4. So we can say f inverse of x is equal to 5 to the x minus 1 over 4. I think I've been forgetting that step, so let's go back here and we can say f inverse of x is equal to the log 1.5 x minus 4 to the 1, right? Go back and say, oops, do it there either. So we can say f inverse of x is equal to log 5 2x on the minus 1 all over 4. And then what else? Oh, that's it. So keep in mind, it's a little technical stuff that if you forget it,
think that's the end of the notes right there.
Okay, and we can stop the notes for now.